Hello, students. Welcome back to the second part of our study of Newton's laws of motion. In the previous class, we had a session on the first law of motion, according to which every object continues in its state of rest or uniform motion in a straight line unless acted upon by an external unbalanced force. The property or tendency of opposing any change in the state of rest or uniform motion by any object is called inertia. A body might have an inertia of rest, motion, or direction. We had also discussed a couple of examples based upon the common observations from our day to day life and tried to analyze those situations using Newton's first law of motion. I hope the assignment given to you has been successfully completed. So now we will continue with our study on Newton's second law of motion. Prior to that, it is very necessary to understand a physical quantity that is so important in describing the motion of any object. It is momentum. Momentum, or what may be referred to as linear momentum. Why is it called linear momentum? Because we are considering linear motion of any object. An object is moving in a straight line. So the momentum of that object can be referred to as linear momentum, which is the product of its mass and velocity. That is how we define momentum, the product of mass of an object and its velocity. So formula of momentum comes directly from its definition. Momentum equals mass multiplied velocity. That is P equals m into V. P is the symbol for momentum, m stands for mass, and V obviously is velocity. Now as velocity is a vector quantity, so momentum is also an vector quantity whose direction is in the direction of velocity. From the formula, we get the SI unit of momentum as kg meter per second. SI unit of momentum is kg meter per second. Statement of Newton's second law of motion. The rate of change of momentum of a body is directly proportional to the applied force and takes place in the direction of the applied force. For the sake of convenience, we can divide the statement into two parts. The rate of change of momentum of a body is directly proportional to the applied force. Whatever force is applied to any object, that force always tends to bring about a change in the state of the object. That is something that we have already discussed about the effects of force. So when a force is applied on any object, it will try to bring about a change in state. Now change in state may be change in state of motion. Like if the object was moving with some velocity, on application of force, either there may be some increase in velocity or decrease in velocity. Now momentum is the product of mass and velocity. So if velocity changes, so will momentum. So this change in momentum is directly proportional. Now proportional means dependent. So the change in momentum is directly dependent on the applied force. Now there is a term called rate of change. So rate of change, this means we are trying to find out the change in momentum with respect to time. So what is the change in momentum of a body with respect to time is directly dependent on the force applied. Now this is one part. The second part tells us about the direction in which this change is going to take place. So the change will take place in the direction of applied force. The direction in which the effort, the direction in which the force has been applied will decide the direction of change of momentum. So this is what Newton's second law of motion tells us. Now the next important task for us will be to study a mathematical representation of this law. For this again we will try to take help of the law by distributing it into two parts, and we will use this much part. The rate of change of momentum of a body is directly proportional to the applied force. Rate of change of momentum is directly proportional to the applied force. What is rate of change of momentum? For that, let us first of all understand what is change of momentum. Change of momentum is actually final momentum minus initial momentum. Now, here I would like to ask you one question. If there is a change in momentum, then actually what is changing? Momentum is a product of mass and velocity. So obviously, change in momentum will take place due to change in either of these two values, mass and velocity. Out of these two, mass is a constant quantity. It does not change. So obviously, change in momentum is directly related to change in velocity. So whenever we talk about change in momentum, actually there is a change in velocity of the object. So initially, if the velocity is u, and finally the velocity becomes t. This means the velocity of the body is u when time is equal to 0, and velocity becomes v when time becomes t. So now change in momentum will be equal to final momentum minus initial momentum. This will be the formula for change in momentum. Now, when we say rate of change in momentum, this means change in momentum divided by time. So rate of change of momentum will be equal to change in momentum divided by time, and that will be equal to mv minus mu, that is the change in momentum, divided by time, the time taken, and ultimately we get mv minus mu divided by t. This is the rate of change of momentum. Now, according to second law, rate of change in momentum is directly proportional to applied force. If I represent applied force with F, then rate of change in momentum is directly proportional to the applied force, and it takes place in the direction of force. That's why both are having similar sign. If the direction would have been opposite, we would have put a negative sign. But since the law says that the rate of change in momentum takes place in the direction of force, so this would be the expression. Now let us proceed from here. If we take m as common, now does the bracketed term appear a bit familiar to you? Obviously, it represents acceleration. So therefore, F is proportional to m into a. Now, you should know that whenever we want to replace this proportionality sign with an equal to sign, we have to introduce a constant. So, we replace the proportionality sign with an equal to sign with a constant k times m into a. This k is a constant quantity. In SI units, this k is equal to 1. Therefore, we get F equal to m into a, and that is the formula for force. So using Newton's second law of motion, we can derive an expression for force, and that turns out to be a product of mass and acceleration. Right at this moment, I would like to tell you that you should never define force as it is equal to the product of mass and acceleration. No. The definition for force is something that we have discussed earlier. It is an external cause which tends to bring about a change in the state of the object. It can bring about a change in the shape and size of the object. This is the formula for force. If a question is asked which law of motion gives the definition of force, then Newton's first law gives us the definition of motion, definition of force. Newton's first law of motion gives us the definition of force. Then which law tells us the formula of force? Second law. And obviously from the formula we can obtain the unit. So that is exactly what we are going to do next. We are going to define the SI unit of force using this formula. So Newton's second law of motion gives us the formula for force as well as the SI unit of force. So SI unit of force. SI unit of force is Newton, represented by capital letter N. Now what is 1 Newton? F is equal to mass into acceleration. So if mass is 1 kg and acceleration is 1 meter per second square, then force is 1 Newton. So 1 Newton is equal to 1 kg meter per second square. This is how we define 1 Newton. So a force is said to have a magnitude of 1 Newton if it produces an acceleration of 1 meter per second square in a body of mass 1 kg. This is the definition for the SI unit of force. A force is said to have a magnitude of 1 Newton if it produces an acceleration of 1 meter per second square in a body of mass 1 kg. Now, does anybody remember how do we measure force? We can measure force with the help of a spring balance. Now we will discuss some common situations using Newton's second law of motion. This is a bit similar to what we have done in our previous class also. There we applied Newton's first law to analyze some situations. Similarly, we will be analyzing some common situations using Newton's second law. The first one, a fielder pulls his hands gradually with the moving ball while holding a catch. Now I am quite sure that all of you might be having a great liking for watching cricket matches, and you might have seen that while taking a catch, while catching a ball, a fielder always moves his hands backwards. Why does he move his hands backwards? What is the purpose of doing that? Because he wants to save his hands from getting injured. What happens when a batsman hits the ball? The ball comes to the fielder with a tremendous velocity. It is moving with a very high velocity, due to which it has got a very high momentum. Now, as soon as the player is going to catch the ball, it is going to come to the state of rest instantly. If the player is not moving his hands backwards, then the ball will come to rest instantly. In that situation, what is going to happen? Just imagine F is directly proportional to mv minus mu divided by t. So initial velocity is very high, final velocity becomes 0. So in a very small time, if the ball is brought to the state of rest, if t is small, force will be very high, and this stopping force will be acting on the hands of the player, and obviously the player will get hurt. In order to avoid that situation, what is done? The time to bring the ball to the state of rest is increased by moving the hands backward. By moving his hands backward, the player is increasing the time of catch. That is, the person increases the time to bring about a given change in momentum, and hence rate of change of momentum decreases. So as time increases, force decreases. So as less stopping force acts on the player's hand, so the possibility of getting hurt reduces. So this is the reason why a fielder, why a player moves his hands backwards while catching a ball. Similarly, after a high jump, why does an athlete fall on a cushion bed or a sand bed? When a person is taking a high jump, he runs through some distance, and by doing so, he gains some momentum. But as soon he hits the ground, his body instantly comes to rest. So the rate of change of momentum will be very high, because the time in which the body of the person is coming to rest is very small, and as such a huge amount of stopping force is going to act on the body of the athlete. This stopping force will be exerted by the ground on the body of the athlete, due to which the athlete will suffer severe injury. So obviously this needs to be avoided. So after a high jump, an athlete falls on a cushion bed. In a high jump athletic event, the athletes are made to fall either on a cushion bed or sand bed. This is to increase the time of the athlete's fall to stop after making the jump. This decreases the rate of change of momentum and hence the force. So the athlete does not suffer any injury. Now, you might have all seen that a karate player can break some tiles in a single blow. So, a question arises, how can a karate player break a pile of tiles with a single blow of his hand? Obviously, there is a lot of practice, there is a lot of precision, but what is the reason behind it? What technique is actually working? How a single blow of his hand is good enough to break so many tiles? Because the hand of the player strikes the pile very fast. The contact time between the hand and the tiles is very small. If the time is less, the force will be high. So a huge amount of force is acting on the tiles. The entire momentum of the fast moving hand is reduced to zero in a very short time. So if the time is less, force is high, and this huge force is responsible for breaking the bunch of tiles in a single blow. Now a situation that we had analyzed using first law, use of seat belts. We had discussed why is it advisable to use seat belts while driving a car, because it saves us from any injury in case of any accident. We had explained this question using the concept of inertia as when a car comes to a state of rest all of a sudden, in case of an accident, our body has a tendency to move forward. But if we are tied to the seat belts are not going to allow us to move forward and thereby reduce the possibility of getting any injury. But how can we analyze the same situation using Newton's second law of motion? So as you can see in the picture, that if a person is tied to a seat belt in the fixed position, it keeps the passenger in a fixed position in the vehicle even when the vehicle is out of control and rolls. It reduces forces on a passenger during a collision. When there is a change in moment, the seat belt increases the amount of time it takes for the passenger to stop. Seat belts are stretchable in nature. As the seat belts are stretchable, as you can see in the second picture, it distributes the force on the strongest parts of the body, the hip and the shoulder, hence protecting the spine and the head. So obviously it is always advisable to use seat belts. Nowadays we are also having airbags fitted in the car. So both seat belts and airbags are fitted in the car to help us in case of any accident, to avoid any injury. So Newton's second law relates to seat belts because the law states that the greater the force, the, the greater is the acceleration. The greater the mass, the less acceleration. When you are wearing a seat belt, it obviously stops you from accelerating. So wearing seat belt is compulsory. Whenever we are traveling in a car, we should be using seat belts, because in case of any accident, if the car stops suddenly, the seat belts will increase the time in which our body is coming to rest. Our body will gradually come to rest, and this will stop any possibility of us getting injured by moving forward with the tremendous amount of speed. So we will be saved from any fatal injury. So these are a few questions that we can discuss using Newton's second law of motion. Newton's second law of motion is extremely important because it is referred to as the real law of motion. Today there is an assignment on your part. You will try to answer this question, that why Newton's second law is called the real law. Why Newton's second law is called the real law of motion? What is the reason behind it? We will try to find out an answer to this question, and we will discuss this in our next class. Thank you.